Okay, here we go. All right, we're going to do moles volume relationship. Okay. First question here: how do we measure the amount of a gas? How is this different than measuring the amount of a solid or a liquid? Okay. Problem with gases is they don't have a definite shape or definite volume. Okay. So for solids and liquids, usually what we do is we put them on a balance. We weigh them out. How do we measure the amount of a gas? We're going to do it with volume. How much space it takes up. We're not usually measuring it by mass. If we know the volume, you can change it back to mass and figure out what the mass is. But gases usually weigh pretty light, so we usually look at our volume. Okay? Gases are most empty spaces, so to answer this question, fill in 2 sentences about, so hit pause, about gases. How do we measure the amount of a gas? And also, Google this. I want you guys to type this, measure amount of a gas, into Google, see what you have here. Alright, volume of 1 mole of gas. All gases occupy 22.4 liters at standard temperature and pressure. Okay, this is 0 degrees Celsius and 1 atm. Okay, this is standard temperature and standard pressure. Okay, we'll talk a little bit more about this. Scroll down. Here are some moles, and this makes sense. H2, diatomic. Okay, carbon dioxide, CO2, ammonia gas, NH3, argon gas, very poisonous. Okay, if we have 1 mole of each of these, we know already the number of particles they take up. 1 mole is always 6.02 times 10 to the 23rd. Okay, over here we have their molar mass. Okay, this is already done for you. 2.02 grams per mole, 32, 44.01, 17.04, 39.95. Okay, this is how much they weigh. And over here, this is how much space they take up. 22.4 liters for every 1 mole. So let's do 1 or 2 of our example problems. What's the volume of 1.25 moles of gas at standard temperature and pressure? Okay, this is just notes right now. We have not 1 mole, but 1.25 moles. We want to know what is our volume. Same thing for color coding. We're looking for volume, and we're given moles. Okay, so 1.25 moles, and we're going to volume. We know we're going to have 1 mole down here. Look at your chart, 1 mole, and we need to know volume. Same thing we've done, straight up, 22.4 multiplied by 22.4 liters. Okay, not too shabby. Moles cancels out. Take this, multiply it out, box your answer here. Go ahead, also do number 2. Okay, flip it over, and we're going to look at moles to particles. This I want to practice because we haven't used the calculators too much. Okay, we got 2.45 moles of potassium. Okay, and we want to know how many atoms there are. Okay, so if we look at our chart, color coding, we're going from red to yellow. Okay, we're going to mark that on here. Red to yellow. Okay, and because we're going from red to yellow, if we look at our directions, we're going to multiply red to yellow. We're multiplying by 6.02 times 10 to the 23rd. Avogadro's number. Okay, so let's set this up. 2.45 moles of potassium, Ka. And we are multiplying by 6.02 times 10 to the 23rd, okay? In this case, it's atoms for every 1 mole, okay? If you don't know what goes down at the bottom, it's whatever is here. You need to cancel out. Moles, moles. Let's plug these guys in, okay? 2.45 times 6.02. This gets us equals 14.7. Our 4 tells us to say the same. 14.7 times 10 to the 23rd. Okay, can you see that? Atoms. Got to have your units here. Okay, so I didn't plug this last part into the calculator. What your calculator will tell you, it's going to put every answer in scientific notation. It's going to make sure that whatever this number is, it's going to change it to between 0 and 10. So what your calculator would do if you type this in, it would tell that it's 1.47 times 10 to the 24th power, because it moves your decimal over one more spot. These are both the same answer. Okay? The other thing it might say, depending if you're using the other one, it might say that it has 1.47 times 10, 1.47 to the 25th, just getting rid of the 10th. Okay? I would just not bother putting this into a calculator. This answer is fine. Right now, I think that's the best thing to do. Okay? Go ahead, do problems 2, 3, and 4. We're setting these up all the same. We're looking for molecules, atoms, atoms. Okay? And they gave you moles, moles, moles. So almost all of these are red to yellow, because down here we have particles, atoms, and molecules.